Hello and welcome to the next tutorial of the FPS series, and in this tutorial apparently we have these two things to do. So fire up Blender and make some simple weapon model, and the second thing to do is to make the actual weapon class, which is I think a pretty interesting class. But before I go into that, there are a few bugs which I found, so let's fix those first. So if I start the game at the current state, I have made a new map. As you can see, it's a bit bigger, so we can test it, and I changed the spawn point just above the level, so 0, 10, 0. This is the free coordinate XYZ. Problem 1.0 is that the colors. I changed the color, all of these different planes to a different color, but as you can see, this plane has a green color and this plane has green color, and apparently these colors are not even correct, since for example I made the floor with a gray color. The problem is, although I mentioned in the object loader tutorial, so if it is a collision plane, then don't insert it to the face. But now, if it is a collision plane, we insert it to the vector of collision vector, but we insert it to among the faces as well. Because I forget to place an else here. So if it is a collision plane, then only insert it into the collision plane vector, not insert it into the faces. Else, so if it is not a collision plane, then don't insert it to the collision plane, but just insert it to the face. So now with a simple else statement, I can fix this first error. So I close the else right here, and we are finished with the first error. So if I compile the program again and run it, then it should give the correct color. That's right, as you can see, these are the correct colors. Now the problem, oh, you can't see it because it's not on the screen for you. Now these are the correct colors. Now if I try to move right now, so try to move forward, backward, right, left, I cannot even move, just a little bit, but if I just press the key, I cannot move forward. And that's because we have a little bug in the player.cpp file right here in the update function. The problem here is that I set the position always back to the current position. So here I get the position, so the center position, and I add the gravity to it and set it back to there. So not matter where I move, I always basically stuck in the same place. This is again very simple to fix. Just not set the position right here, but add the gravity to the new position, so our current location. So new position plus equal direction. That's right, that should fix the second error. So I compile it and run it, and now I can move in move. So yeah, and the collision detection seems to work fine, so I cannot go out, not here, not even here, so I cannot go out from the actual level anywhere. This will be a great test level, since it's very simple and simple to load, quick to load. Right, so that was actually the two error. I believe we don't have any more. So I changed the position right here somewhere, wherever I put the player. Yeah, right here. So I changed this 0, 30, 0 position. It's not really matter. The only thing it's matter that it's above the level, so I will fall down to the level. Alright, I believe we are ready to do the today tutorial, which is actually the weapon class. Alright, let's make the two files. Okay, I just created the weapon.age and the weapon.cpp file, and this will be a very long class. I hope I can make it in one tutorial. So let's start to create it. First of all, let's make our inclusion guard again. So if not defined weapon_age, then we define the weapon_age and make an endif right here, so we can avoid the multiple inclusion errors. So the class name is weapon, and this has quite a few, so a lot of member variables. So first of all, let's make a few include, because we have to include the vector, because we will store the frames in vectors. Then we include the IO stream, just for testing purposes, IO stream. Then we include the normal GL header file, so gl/gl.age and gl/glu.age for the utility library, although that may not be necessary for this class, but make sure that we have everything that we need. Okay, we might need the SDL, so sdl/sdl.age. What else do we need? probably we will need the vector class to store coordinates, so vector3d.h, which we have created earlier, and probably that's all. Maybe if later on something comes to my mind, we will add there. So first of all, we need to store all of the frames of the animation of the weapon, since you know, we will animate it. We will do that with a vector which store unsigned ints, which, if you remember, an unsigned int is basically an index to, or an identifier, better, to the current loaded object, so call it frames. And we need to store another unsigned int. This is the outer look of the weapon, so outer view, let's make it that. So this is how the weapon looks from the outside, because whenever you drop the weapon, there is that spinning weapon, if you have seen the demonstration video, and that's a different model than the weapon you are holding in your hand. Okay, and we need to store an unsigned int and normal animation. This is how long the animation, basically a normal animation, so whenever you are not shooting and not reloading. Similarly, I made an unsigned int fire animation. This is long how many frames the fire animation is after the normal animation. And we make one more. This is the reload animation. Reload animation. Perfect. So for example, if this free number contains 2, 3, 4, that's pretty much mean then 0 and 1 is the normal animation. So this is continuously play 0, 1, 0, 1, 0, 1 whenever you are not shooting or reloading. Then 2, 3, 4 is the actual fire animation. So whenever you fire with a weapon, the 2, 3, 4 frame will play, and the reload animation will be the 5, 6, 7, 8. This is the reload animation. So whenever you reload, this sequence of image will play. That's this free variable mean, just in a practical example, although probably we'll use a bigger number than 2, 3, 4, 30 frames, for example, a reload or something. That's about 1 second. Okay, and then we need the current position of the weapon, which it should be. So vector 3d, and what should I call this variable? I don't want to call it corpus because that's another variable. So this is current position expected. That's right, position expected, and I will totally forget this name, and rotation expected. So this is basically what wherever your weapon should go. I will explain it in a moment, just we need a few more variables to do that. Okay, and the next is a vector 3d again, and this is the position, and actually this should be, oh no, everything is fine. So vector 3d, and this is the rotation. So these two variables basically contain, whenever you're not aiming with the weapon, what is the position and the rotation of the weapon. So when you not aiming. Okay, and the next two variables, so this is vector 3d aim position, and again vector 3d aim rotation. So obviously these two is what is the rotation and the position of the weapon when you aiming, so it's quite obvious when you aiming. Okay, and we have two more vector 3d variables about the position. This is the vector 3d corpus, so the current position, and vector 3d current rotation. This is the current position. So let me explain. This position expected, whenever you're not aiming with the weapon, for example, will contain the same value as this position and rotation. Whenever you're aiming with the weapon, this contains the aim position and the aim rotation of the weapon. The current position and the current rotation will store the current position, and with some constant it will continuously try to go from this current position to the position expected. So this will result that the weapon continuously go to a position, not just whenever you press the right mouse button to aim, it will not just immediately pop there, but slightly go there from the current position. The current position, for example, first it is a position, first this two variable, and then it will slowly go to this aim position and aim rotation whenever you press the right mouse button. That's about these variables, so quite a lot of variables to store positions, but I think it's paid off whenever you see that it's slightly moving and not just popping right there. Alright, okay, we need two float variables. This is the precision and the aim precision. So whenever you are shooting with a weapon, it will not shoot exactly to the center of the screen. It has some precision. The higher this number, the more precise the weapon is. Obviously, a better weapon is more precise, and whenever you're aiming, it will still not go exactly to the center of the screen, but it will be more precise, obviously. At least that would be logical. Okay, next we need the strength of the weapon. So in strength, this is quite strength. This is quite simple. Whenever you shoot the enemy, how many lives the enemy will lose from this weapon. Obviously, the enemy will lose more weapon from, I don't know, some heavy machine gun than a pistol. Okay, and we need a bunch of flag variables, so boolean values. So bool is aim, so obviously if we are aiming, is reloading, so if we are reloading the weapon, is automatic. If the weapon is automatic or semi-automatic, mean that you can continuously hold down the mouse button, it will shoot, and semi-automatic, you have to press the mouse button and it shoot only once. Okay, and we have an isFired variable. If the weapon is semi-automatic, we have to store if we already fired with this weapon or not. Alright, and we have an interesting variable, it's called isTest. This variable is basically true if it is a test, mean that we can use the keyboard to set the mouse, set the weapon's position and rotation on the screen. So we will not hardcode into the position and the rotation to this weapon class, but we actually set it with the, I don't know, some key in the keyboard, and we can decide where it looks the best, and then we just write down that value and we can use that later on. So I'm not sure if it is clear right now, but it will be clear later on. Okay, then we have a few variables about how many bullets the weapon have. The next variable is unsigned integer, and this is called max bullets in mag. So this is the maximum bullets in the magazine, so which this weapon can hold. So for example 30 for a usual machine gun. The next variable is the bullet in mag, so unsigned integer bullets in mag. So this is currently how many bullets we have in the magazine. Okay, we have another unsigned integer all bullets. This is how many bullets we have for this weapon, and that's about the bullets. Let's go to the speed of the weapon. So we have an unsigned integer, and this is last shot. So how many frames ago did we shoot? How many frames ago did we fire with this weapon? Then we have an unsigned integer speed, so how many frames, that can be shoot a bullet. So for example, if this is 5, then we can shoot a bullet in every 5 frames. So I will not comment that. Then the next few parameter is for the animation again. So this is an unsigned integer current frame, which is the current frame. We can, according to the current frame, run the animation and these variables. So these variables are needed. And one more is the unsigned int, and this is the core mode. So this will be 1 for the normal, and 2 for the fire, and 3 for reload. Of course, we can add more of these modes by just simple adding more possible cases to the switch statement later on. One more thing is the name of the weapon, so std string and name of the weapon, so I don't know, AK-47 or something, it can contain that. Right, that was mostly all of the member variable which we have needed. Quite a lot of member variables. And in the public, we obviously have the constructor, which will weight a bunch of parameters. For example, it weights a vector, so std vector with unsigned int reference actually, and this is the animation. So as we usually add animation, so just simple add the vector, and this frames will be equal to this anim. Then we have the outer look, so unsigned int outer look ol, for example. Next one is the unsigned int normal animation, and similarly I will get the fire animation and reload animation. So I get these variables. So we filled up already these variables. Position expected we don't have to fill up. The position we have to. So vector 3D, and this will be the position, vector 3D rotation, vector 3D aim position, vector 3D, and this will be the aim rotation. Okay, we have filled up these variables. Current position we don't have to fill up. Precision and aim precision, so we have to fill up those. Float precision and float aim precision. What else do we have? Okay, the strength of the weapon, so int str, and we don't have to fill up these flags, we will fill up them in the constructor. Okay, I mean that we don't have to pass it as a parameter, we can fill up without them. The max bullets, we have to fill up that as well, so int max bullets. Okay, and bullets in mag, it will be defaultly the maximum bullets which can be placed in there. All bullets, so we have to get that, all bullets. Let's make it with double L. Okay, the speed, we have to get that, int speed, current frame mode, and the name of the weapon, obviously, so this will be a conchar name. Wow, that was a long constructor. I mean a very long constructor. I usually not like to give that much amount of parameter to one simple constructor or one simple function. The destructor will be maybe empty because again we don't really have anything dynamically allocated right here. Okay, and then we need update and show function, so void update and void show. This is the typical update and show function. Update, for example, increase the last shot frame, so how many frames ago did we shoot, and so on. Okay, and then we need a bunch of getter and setter variables functions, so void aim, for example, this will, whenever you press the right mouse button, then this function will be called and the weapon will be aimed if it is possible. Then one important function, which is actually not even a getter function, is the fire function, bool fire. The boolean will represent if the fire actually happened or not. So if we actually shoot a bullet, this will return true, else it will just return false. And actually it waits a few parameters like vector 3D, and the first parameter is the result, so direction. This will be where actually the bullet goes, so the trajectory of the bullet. And the second parameter is the where the camera is looking at, so this will be a vector 3D and cam direction. So the second parameter is actually where the camera is looking at, so we can calculate the new direction. That's two parameters. And then back to the getter and setter function. So we have the opposite of this function is the void stop fire. The stop fire will stop the firing, so if it is a semi-automatic weapon, the is fired variable will become true whenever we fired, and whenever we use the stop fire, the is fired variable will become false. That's right. And then we have to start the reload with the reload function, which will check a lot of expression and determine if you can reload or not, how many bullets after reload will you have in the weapon. Okay, and then we have a test function. I will explain that later whenever we make the actual implementation of this test function. Okay, we need to be able to add bullets, so void add bullets. So whenever you I don't know, pick up a magazine from the ground, then you add bullets, some bullets to your weapon, so inside num, and of course the set bullet, which will set the bullet to whatever number you say. So these are just pretty simple functions. I probably talk more about them than it's implemented. Okay, get strength, so whenever the enemy is hit with the weapon, with the get strength, with this function we can get the strength of the weapon and subtract that strength from the health of the zombie. Okay, and int get ammo, so how many ammo do you have, int get all ammo, so how many so all of the what do I want to say, so get all bullets is this, return with this, and get bullets will return with this. Okay, next on the list is get name. This is useful for later on for the menu. So whenever you will write what weapon do you have in the hand of the player, so this is the get name. And then the next thing to do is the get animation, although this might not be as useful. So vector unsigned int, and this is the get animation. Perfect. And the boolean is aimed. So if the player is aimed with the weapon, this will return true as false. So for example, you cannot sprint where you are aiming. Okay, and one more is the unsigned int get outer view. So this will be later on needed to determine how the weapon look like from the outside. I will place the aim right here. Alright, that was all the function. I said it will be a quite long class actually, but I think we can go to implement this function. So I will just copy and paste, and again as usually I pause it while I add the weapon : between before every line. So weapon : and format a little bit. So I will be back. Alright, I finished it. I structured the code a little bit, so deleted the semicolon and tabulators before, and actually I did a little bit of work by making this simple getter and setter function, so I will not take your time with that since these are very simple. Just return with the variable which I refer to in the name of the function. That's right, so I've already have these, so we have to actually implement the actual interesting functions. Okay, first of all let's start with the constructor, and this will be a long constructor. Okay, so frames equals to the animation, and the outer view equal to the outer loop. Okay, and the normal animation equal to NA, the reload animation equals to RA, the fire animation equals to FA. Okay, so what else? Precision equals to press, and aim precision equals to A press. Actually, this will be a bit complicated since I will divide with this number. We don't want to divide by 0, so if it is 0, if it is not 0, then just simply get the precision, else, so colon, actually not 0, so what? So not 0, then a question mark, then get the precision, colon, else we will just set it to some very small number. So if the user add 0 to the place of precision, then we just get a very small number. Similarly, I will do the A precision, since we don't like to divide by 0, still not like to do that. Okay, we have these. What else? Alright, position equal to position, rotation equals to rotation, aim position equals to A pos, aim rotation equals to A rot. Okay, what else do we have? A precision, the STR, so the strength of the weapon, so strength equal STR. All bullets equals to all ball. Okay, what else? The max bullet is the max bullets in mag, that is equal to max B. Speed of the weapon is equal to SP, and the name of the weapon is equal to NA, as I said. Okay, we have set quite a few variables, but I think probably we missed some. So we set these, position expected, so position underscore expected equal to position. So whenever we first just initialize the weapon, we don't aiming with the weapon, and rotation expected is equal to rotation. So this basically means that whenever we create a weapon, we just want we don't want to aim with the weapon. Next, so let's go to position. Aim position, we set this current position, and the current position is to current position is equal to position, and current rotation is equal to rotation. That's correct. Okay, what else do we have here? Precision, we set those. Oh, we have this bunch of flags. Okay, so is aim equal to false, we are not aiming with the weapon. Is reloading equal to false, we are not reloading. Is automatic is equal, oh, we should get this. So bool and is a like is automatic, and I add it here as well. So bool is a, so is automatic. So we get that by passing the parameter is automatic equal to is a. I said is a. Alright, is fired, that equals to 4, so whenever we just create a weapon we have not fired yet. And is test, let this be true. For a moment later on I will explain what it exactly does. As I said, the destructor will be empty at the moment. Oh, let me see, do we have everything? So max bullets in mag, we have that. Bullets in mag equal to max bullets in mag. So max bullets in mag. So whenever we create a weapon, the clip of the weapon or magazine of the HUD that is called is always at maximum. Okay, all bullets we have. Last shot. How many frames ago did we shoot? Let's make it 1000, since we actually have not shot yet. So let's just make a big number. There are no weapons which takes more than 1000 frames to shoot 2 bullets. Okay, the current frame is equal to 0. Current frame is equal to 0, so whenever we create a weapon we don't want to yet play any animation yet. So actually we want to play animation, just we start from the first frame. And the current mode, so cur mode is equal to 1, means it's normal animation, we are not firing or reloading yet. Okay, and we set the name. Alright, we have everything set in here. That was the longest constructor ever. Okay, the next thing, destructor. This is the shortest destructor ever, since we will not destruct anything. Okay, the next is the update. The update function first called this test function, which we have not yet created. As I said, whenever this is test variable 2, we can move the weapon around the screen, so we can test what is the best position for that weapon. Okay, the last shot, we increase the last shot, so 1 frame has passed, so 1 frame. So if we shot 10 frames ago, then we shot actually 11 frames ago, since 1 frame has passed. Okay, and the current frame ++, so we try to play the animation. And now it comes to whenever we just set back these frames to the current frame. So if the current mode is equal to 1, so it is normal. I add a little annotation here, normal. So if it is a normal mode, then we check if the current frame, so if the current frame is greater or equal than the normal animation -1. So back to the example I made up here. So if I place 2, it means we have 2 images, 2 frames with the normal animation. This will pretty much mean that 0 and then 1, 0 and then 1. This will be 2 image played. So if the current frame is equal to 2, then we actually have to set it back. So actually I wrote it wrong. We don't need this equal, this -1, we need the equal. So if the current frame is 2, then we set it back to 0. Then the current frame is equal to 0, so cur frame is equal to 0. Okay, as if the mode is 2, as if cur mode is equal to 2, so if we are firing with the weapon, then we have to do one more check in here. So if we are at the end of the animation, so the current frame is greater or equal than the normal animation plus the fire animation. Okay, back to the example. So in this case, the 2 plus 3 is equal to 5. So if we are in the 5th frame, then we set it back to 2. Yeah, then we set it back to 2. So if it is greater or equal than this sum. Okay, and one more check is needed actually. See if it is an automatic weapon, so is automatic and is fired. So if this is an automatic weapon and we already finished and we are still firing with the weapon, so holding down the mouse button, then we actually set it back. So cur frame is equal to the normal animation. So in that case, this means that whenever we are the 5th place, so we play the animation, we set it back to the beginning of the animation and play the animation again. Okay, and I just realized that this may cause problems, so may be a bug. Okay, else maybe later on we will try to set it so make it good. As the cur mode is equal to 1, and the curve frame is equal to 0. So it basically means once we shut, we go back to the normal animation. Okay, and one more things to do, as if curve mode is equal to 3, so we are reloading the weapon, then again we check if we are at the end of the reload animation, so curve frame is greater or equal than normal animation plus fire animation plus the reload animation. If this is true, then we are at the end of the reload animation, so we go back to the beginning of the animation, so the normal animation, so curve mode equal to 1 and current frame is equal to 0, and is reloading equal to 4. Since we are not reloading anymore, we finished with reloading. Alright, and now we have the animation correctly set up, so the current frame will continuously increase, and whenever we finished with one kind of animation, we just set it back logically. Next thing to do is to actually do this weapon moving things I explained here, so with this position expected and position, rotation, so on. So first of all, we make a vector 3D object and call this TMP vec, like I always call variables TMP because they are temporary variables. So I need to subtract the expected position, so the current position and minus the expected position, so position underscore expected. I do that because we now get a vector which points from the position which we want. No, it's pointing from the current position to the position that expected that we want to reach. So now we have a vector which basically show where the weapon should move. And now we actually have to normalize this vector. So tmp vec dot normalize. The normalize just set the length of this vector to 1, so we can multiply this by a value, and it will always move with that value. So you will see what I mean now. So multiply equal by 0.3. This is simple mean that this weapon will always move 0.3, so 0.3 unit to the direction we want to move, so the expected direction, expected position. Alright, and I actually have to check one more thing, because the problem is that let me again draw an example. So the expected position, let it be 0, 0, 0, and the current position, let it be 0.2 and 0.2 and 0.2. Alright, now whenever this vector try to move to the 0 position, it will actually see that it should move downward, so it should decrease all of these values. So we move with 0.3 units, so it will be minus 0.1, minus 0.1, minus 0.1. Again, it's the next time it will see that it should move upward, so this will add 0.3 to it, so it will be 0.2, 0.2, 0.2, and here is the problem. It will basically stuck in a loop, and our soldier will look like it has some Parkinson disease or something, because it will always move the position a little bit back and a little bit the other direction, and so on and so forth. And to fix this error, basically we do is, if this current, the absolute value of this current value is less than the 0.3, so less than so it is very close, basically we say, then we just set it to equal with the current position. So we get the absolute value of the current, so of the position expected minus the dot x minus the current position dot x, and if it is less than 0.3, and similarly the y and the z coordinates too, so y and z. Okay, so if all of these are fairly close to the expected value, then we just set it to the expected value. So then the current position is equal to position underscore expected. I hope it's clear why I do that. In this way, this will be a null vector next time, and the null vector normalized is a null vector as well. And because it's a null vector, then it will basically not move, it will be just in the current position. Okay, and I have to do the exact same thing with the rotation as well, so let me copy and paste in here. Okay, the only thing is not current position but current rotation, and not position expected but rotation expected. So this is basically a kind of linear interpolation, if you like. Okay, and current rotation, and again I copy and paste that, current rotation and current rotation, and if it is true, then the current rotation equals to rotation expected. That's right. So this is basically a kind of linear interpolation to move the weapon to the desired position. That was about the update function. Since we are finished, what is the next function? The show function. The show function basically go to the current rotation and current location, and it will draw that there. So first of all, we need to use the GL push matrix function, so we will not screw up our transformation matrix outside. So GL push matrix and GL pop matrix, probably you already know that. So if we have a translation or a rotation right here in the show function, then it will screw everything else. So yeah, that's basically it. So GL translate F, and I just move to the current position .x, the current position .y, and the current position .z. Right, and then I do the rotation stuff. So GL rotate F, and I do the rotation at current rotation .x, and I do that rotation in the x-axis, obviously 0 0. Similarly, I do the y in the y-axis and the z in the z-axis. Okay, so 1 and 1 and y and z. Perfect. Now we have to just call the list, so the display list, GL call list. It will call a display list, and the display list number is inside the frames, and it is the current frame. So for example, these frames contain all of the frames of the animation, and the current frame is, for example, 1 mean the 0 mean the first frame from these frames. I mean, it's quite obvious. Okay, next thing is the fire. This is an interesting function. First of all, if we are reloading, so is reloading, then we are just returned with false, since we cannot shoot whenever we're reloading. We are reloading, not shooting, obviously. Now we have to check if the weapon is automatic. So if we have an automatic weapon, so if we don't have an automatic weapon, or we have so we have a semi-automatic weapon and we have not yet fired, so not is fired, or this is an so this is automatic weapon, or this is an automatic weapon, then we can fire. So if it is a semi-automatic and we just click the button, we can fire, or if it is an automatic weapon and not matter if we just click the button or hold down the mouse button, we can fire. Okay, we need to check one more thing. If the last shot, so the last time we shoot the weapon, is greater or equal than speed. So remember, this last shot is how many frames ago did we shoot the weapon, and the speed is how many frames is needed to shoot the weapon. So for example, if we shoot the weapon 10 frames ago, but only every 20 frames we can shoot, then we cannot shoot, obviously. Okay, then here we have to check if we have actual bullets in the clip to shoot. So if bullets in mag, so we have bullets in the mag, so greater than 0, then we can pretty much fire. So now we have to check if we are aiming or not. So if is aim, so if we are aiming with the weapon, else if we are not aiming with the weapon, then we have to do different things. So here we have to set the direction, and this direction will be equal, direction.x will be equal to the direction.x, and now at this position the weapon will always shoot the exact center of the screen, so exactly the center. We don't really want that, since yeah, we don't really want that. To do that, to solve this problem, we actually add a random number to the x, y, and z coordinates. So we add a float, and we get a random number, and I think we need an include file for that, since we don't include the cstdlib. So let's include the cstdlib. Okay, back to the function. So we add the random number. Obviously, higher this number, after the percent sign, the more unprecise the weapon will be. And I subtract -1, so this will be basically get a number between, oh no, this is 3. So now it's get either 1, 1, 0 or -1, if I am correct. Maybe I'm not sure. Okay, and then I divide this with the aim precision. That's why we don't. That's why we cannot let the aim precision to be 0. So the higher the aim precision is, the higher number will divide this random number, and because of that, the smaller this number will be. So because the smaller this number will be, the more precise the weapon will be. That's the basic idea behind it. And actually I just copy that to here and here. Okay, the aim precision, the other precision, so when we are not aiming, is pretty much the same, except we don't use aim precision, we just use simple precision. Okay, now we have shooted the weapon, and the direction XYZ coordinate stores, the direction XYZ coordinate stores the direction where we shoot. Later we can use the ray tracing with this direction to get if we shoot anything or not. Okay, before we quit, then we add an is fired equals to true, so we already fired with the weapon. Last shot is equal to 0, we just shot with the weapon. We decrease the number of bullets in the magazine, so num minus. Okay, so obviously we shoot out 1 bullet, so yeah. Okay, and the current frame is equal to the normal animation. Again, back to the example. So if we are shooting, then the current frame is equal to 2, so it will be playing the fire animation. And the current mode is equal to 2. Current mode is equal to 2. Alright, and we can just return with 1 in this case. Because we have fired, so actually make it true, so it will be more, so it will be a boolean. Okay, and as if we don't have bullets in the magazine, then let's just initialize a reload. So reload and return with false. And actually I return with false here as well. So if any of these if statements is false, so then we just return with false. That's what I said. And if the magazine is empty, then we just reload the weapon. Actually try to reload the weapon, since the reload will check if we have bullets and a lot of other things. Okay, stop fire is a pretty simple, is fired equal to false. So obviously this is needed for the semi-automatic weapon. And here we are at the reload function, as I talked about that. Okay, first of all we have to check if we are already reloading. So if we are not reloading, so is reloading, since we can't reload twice. Okay, and the magazine is not full, so if max bullets in magazine is not equal to the bullets in magazine, so if the clip or whatever it's called magazine is not full, then we can start to reload. Okay, so set the is reloading equal to true. And now we have to set how many bullets should be in the magazine. So if the all bullets, if, as I wanted to write, if the all bullets, so we have more bullets than is needed to fill up the whole clip. So max bullets in mag minus bullets in mag. So if we have enough bullets, then we just subtract how many bullets did we need it. So all bullets minus equal to this. So for example, if 30 mags go into in a magazine and we have 25 in the magazine currently, then we need 5 bullets to fill up the magazine. Quite obvious. And the bullets in magazine mag is equal to max bullets in mag. So we just filled up the whole mag. So we have less bullets than needed to fill up the entire clip. Then we just set the bullets in mag equal to all bullets plus bullets in mag. So if we have 5 bullets only left and we have 5 bullets in the magazine, then we have 10 bullets in in the magazine. So if we add them together, and all bullets is equal to 0, and we don't have any bullets left after that. Okay, and we have to start the animation as well. So current frame equal to normal animation plus fire animation, and the current mode is equal to 3, meaning that we are playing the reload animation. That was pretty much the reload animation, so I think it's quite simple. The aim is coming next. So whenever we call the aim function, we will reverse. If we are aiming, then we will not aim. If we are not aiming, then we will aim. So so if it is aim, and let it be equal to not is aim. So the not is pretty much mean the opposite. So if it was true, then it become false. If it was false, then become true. And now, if we are aiming, so if is aim, then the current rotation, actually no, the rotation underscore expected equals to aim rotation, and the position underscore expected equal to aim position. That's right. And else we basically do the same, just not with the aim, just the normal rotation and the normal position. Perfect. We have this one as well. Next one is the test. Alright, and we are finished. Finally, this was a long class. I barely can talk now. I just talked that much. Okay, the test function, as I said, will be used to place the weapon somewhere on the screen. So first of all, we have to check if the isTest variable is true. Remember, this was the boolean value we just set earlier. And then we have to get the key state. So uint 8 and keys, and let it be equal to SDL get key state null. So it will basically get all the pressed keys. So if the keys and the SDL case some letter, for example, I will use the JKL I and UO for the rotation. So if the J is equal to true, so if we are pressing the J key, then the current position dot x and minus equal to 0.02, so some value. Again, if keys SDL K underscore L is true, then we just add something to the x value, so current position dot x plus equals 0.02, and again I do that all the keys. So SDL K, for example K, then I set the Z current position dot Z, and plus equal, actually this should be on the minus equal 0.02, and again I do the opposite. Let me just copy that. So if I press the K, then I will add something to the Z value, and now we have the position stuff. Let me do the rotation. I actually will just only rotate in the y-axis since I've run out of keys already, that much of keys, but you can do that with the other axis as well. So if I press the U, then I will change the current rotation dot y minus equals something, and if I pressing the O key, then I change the y plus equal the current rotation. So this basically does is just set the value whenever we press one of these keys. And actually one important thing which left is to write out these values, so stdcout, and write out the current position and the current rotation per rot and line. Whew, that was it basically. Okay, and I think we are ready to try to compile this whole thing. But before I actually do that, I go to the player class and actually make some of the player's weapon function. Alright, I'm back, and I opened up the player.h and player.cpp and game.h and game.cpp file, so we can add the weapons here. So first of all, we have to include the header file, obviously. So include and weapon.h. So we included the weapon file. Now we can make a vector of weapons here, right here. So weapon, actually an std vector, and this vector is containing weapons, and the name of this should be weapons. Alright, now we have a bunch of weapons for the player. Actually, at the moment it's empty, but we add a default weapon in the constructor, so we will wait a weapon pointer here and just call it wep or something. Okay, and let's make in the player.cpp, in the constructor, let's just add this weapon. So weapon, wep. Okay, and weapons dot push back wep. Perfect. Now we have a default weapon for our player, and now we actually have to make an integer which stores which weapon is actually on the hand of the player. So int cur wep, like current weapon or something like weapon. I just write it out fully so we can see it. Okay, and make the current weapon equal to the 0. So this will be the default weapon. Whenever we just start the game, we just add this weapon to the player, and this what the player will hold. Alright, let's go to the update function, and in the update function let's just call the update for the weapon. So for int I equals 0, actually we only have to update the current weapon, so weapons cur weapon, and let's just update it right here. So the update, if we go back to the weapon.h file, we can see that the update is it doesn't wait any parameters. Perfect. So we just updated the weapon, and in the show function let's just show the weapon. So weapons cur weapon and show. That's right. And actually I almost forgot one thing. We should make a boolean value right now. So I make it right here. Bool is weapon, because the player not necessarily have a weapon in the hand. So in the constructor, make the is weapon equal to true, so we will have defaultly a weapon in the hand of the player, and we only update and show whenever the player has actually weapon in the hand. So if is weapon, then we update the weapon, and here as well, if is weapon, then we show the weapon. Right. Okay, and what else is here? We should add the few function which will change the weapon and add new weapon. So void add weapon, and this will wait a weapon pointer called wep. Right, and the next is should be the change weapon. So void change weapon, and we just give a number here. So what weapon, and void change weapon down. So whenever I use the, how does it called, mouse scroller, that's right, and I scroll it downward, then I just change the weapon to the previous weapon. So this doesn't wait any parameter. Void change weapon up. If I scroll the mouse wheel to the different direction, then obviously I change the weapon to the opposite way. Okay, and I will make a getter function to the current weapon, so it's a weapon pointer, get weapon, get current weapon rather, get current weapon, and let's see the next. Yeah, we should make a function to change this is weapon variable. So void is void have weapon, or I don't know, have weapon. This will be not really useful at the moment. Later on when we will do the knifing, we will use this, and bool b. Okay, let me just implement these few functions, which are not actually too complex functions, so I believe I can implement it quite quickly. Okay, let me format this code a little bit. Weapon colon colon, and I just copy and paste it everywhere. So paste, 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 paste. Perfect. Okay, add weapon. This is very simple, just weapons.push underscore back wep. Right. Next is change weapon. The change weapon is just check if this num is alright. So if we have that weapon, if weapons.size is less than num, or what? So if the number of weapons we have is greater than num, yeah, that's right, then cur weapon equal to num. Alright, and next change weapon up. This is simple, just cur weapon minus minus, and if the current weapon, so if cur weapon is less than 0, then make the curve weapon equal to weapons.size -1, because the indexing starts from 0, that's why the -1. The change the weapon up function is very similar. Curve weapon plus plus, so I increase the weapon, and if this curve weapon is greater or equal than the size, so weapons.size, then I just set the curve weapon back to 0. Perfect. What get current weapon? Again, a very simple function. I just return with the weapons curve weapon. So I just return with the current weapon, and have weapon just change the is weapon equal to b, is weapon equal to b. Alright, that was all the function necessary to change in the player.cpp file. I added a few functions, changed the constructor so I can add the weapon, and now we shall go to the game.cpp file, and here wherever we create the new player, here I actually should put weapon right here. Alright, so let me just create a weapon. Actually, we should store the weapons in the game.cpp as well. So I make an array of weapons. So right here, std vector weapons, weapon pointer, and weapons. We need that because actually we don't really need that, but I will do the dynamic allocation and deallocation in the game.cpp file. And to do that, we need to we need to remember the address which we should free later on. Okay, so weapons dot push back and the new weapon, and I will pass that 1 billion trillion argument into here. Okay, although we don't have some things yet, like the animation, or we don't really know these values yet. So I will do that in a moment. So we should open up Blender and make the weapon file. That's the next thing to do. Until that, I will just comment out this line. Okay, I will not test this class yet, so although I could try, but I'm pretty sure we have a lot of errors. You know what, why not? Just test this out. So I should go to the correct directory first of all. So fps game _ game, and that's right, and try to compile it, and we will have 1 million trillion billion error, and we shall fix those. So okay, not too much yet. Okay, it's a bit more every line. Let me see. Okay, so first of all, no matching function to call, obviously, because we have to pass the weapon pointer for into the player. For now, just pass null, because we can pass null any pointer, any place of the pointer. Okay, that should fix these first few errors. Next is 100 and what is it, 15 player.cpp. Let's go there and check what's up. Okay, oh, the semicolon. Did I? Okay, I removed all of them except this. Next, 120 weapon member from declared in class weapon. Oh, why not? We have, don't we? Get current weapon. Here it is. I'm not sure. Yeah, let's go to the next one. Okay, 100. Probably got the semicolon. Okay, 43. In what class? It is the weapon.cpp 43. So I will open that and go to that line 43 right here. Okay, the destructor. Okay, I close this. And what's with this line? Destructor or type conversation? Not sure. Let me just compile it again, because I don't really know what error did we fix and what error did we not fix. Okay, we have the same amount of error, about approximately. No add weapon member function declared in weapon. Oh, I see. Let me pause this. Yep, here is the problem. I added the weapon colon instead of player colon, although this is in the player class. So I just changed these, and this should fix a few of these errors. That's right. Okay, we have fixed these. Let's get to destructor. Okay, and in the weapon.cpp we still have something problem in the beginning of the file. Oh, I forget to include the actual header file, so include weapon.h. Alright, and now we maybe fix a few of these errors. Perfect. An error list which can be placed in one single terminal. Okay, NA has been previously declared here, weapon.cpp3. Okay, so NA, here it is the NA, and the name is NA as well. So let's just rename one of these, and the name is not NA, it is NAM now. Alright, next one. Yep, 13, it's a long constructor. 88, redeclaration of TMP-vec. Yeah, I know why it is, because we shouldn't copy the actual declaration. So this vector3d only copy the code which doesn't declare a new variable. Alright, next one is bullet in meg, because it's bullets in meg, so 120, what was it? 129 bullets in meg. Alright, next one, SDL get key state was not declared in this scope. 8 SDL get key state. That's probably because we haven't included the SDL file. We did SDL underscore get key. Oh, a T. I see. Alright. 197 and std : probably missed. Alright. Try to run it again. Oh, we have something more was not declared in this scope. 25 position expected without R. Expected. Okay. Position, another mistype at line. So this position and I. That's right. And no match for call vector3d vector.cpp88. Then just use the equal sign. I believe that should work, or use the change function rather. That's right. And again, try again. That's right, it compiled, although we shouldn't run it since we don't have anything yet which we will see. So first of all, we should fire up Blender and create our simple weapon animation. So that's the next thing on the list. So stay tuned, I will be back. Alright, here we go. I just fired up Blender. This is the newest version. And here we have our default scene. We have one cube and one camera. Doesn't really matter at the moment. Okay, so first of all, let's rescale this little cube. Another thing I forget to mention is that the idea behind this weapon is basically the same as the idea behind the map, that it should be simple as when we testing. So this weapon will be basically a rescaled cube, no texture, nothing really basically. So let's just rescale it. So press letter S on the keyboard and on the Y-axis, so it will be a little not that wide. So and scale it again. Press the key X to do the rescaling on the x-axis, and again rescale it again. So press S, and now don't press X, Y, or Z, just scale it down a little bit. Alright, here this is our weapon. Does it look like a weapon? No. But this will be a test weapon. Later on we can obviously increase the quality of the weapons, make a awesome AK-47 or something animate. For now this is our weapon. Let's rescale it a little more on the Y-axis. Okay, and here's somewhat how this should look like in the game. Like this, or this. Okay, so first of all, let's make some animation to it. So the animation, the normal animation will not have normal animation. You know, you could add the normal animation like breathing effect or something for the weapon, or if it is a futuristic weapon, like electric charge coming out from the weapon. But for now, we just have an empty, not moving weapon as the normal animation, one frame. So when you press the arrow key on the keyboard, you can pretty much, as you can see, go the two different frames. So I go to frame, frame 1, and I just press the key I on the keyboard, and this is insert a keyframe, and just insert the keyframe location, rotation, scale, so loc rot scale, and just click on it. Alright, now we have a keyframe. The next thing is if you remember, the fire animation. Let's make it I don't know, 10 frame long. So let's make it 15 frames long, or 16, let it be 16. Okay, so the fire animation will be for 8 keys it will go backward, and for 8 another key it will go back to the initialized position. So 1 2 3 4 5 6 7 8. Now this is, I pressed the right arrow button 8 times, and let me just make the weapon a little bit back and rotate it on the y-axis. Okay, and press I and insert a keyframe location, rotation, scale. Now if you go back, you can see that this weapon is moving between these two positions. This is basically a linear interpolation, if you don't know. Okay, and let's press the right arrow key 8 more times. So 1 2 3 4 5 6 7 8, about that's correct. And let's put it back to the initialized position. So let me rotate on the Y back. Okay, by the way, you can exactly put it back, but for now it will be okay. And again, I insert a keyframe. So the firing animation, if I press Ctrl A or Shift Alt A, then it will look like this. Right, and now I don't know if it is back or not to the initialized position. It's about back. And now the next thing is the reloading of the weapon. Let's make it 10 frame long. By the way, we should write down this number somewhere. So 1 frame for the normal animation, 16 frames for the fire, and how many frames should the reload take? 20, for example. Okay, and so I go 10 frames. So 1 2 3 4 5 6 7 8 9 10. About okay, and let me just rotate this on the y-axis, and the reload animation will be only that it will rotate here and rotate back. So let me insert a keyframe. So as you can see, whenever we are reloading, the weapon will basically just rotate, and again in the next 10 frame it will rotate back. So 39, so rotate it back to the position it was, like that, or maybe a little bit more. Yeah, okay, and insert a keyframe right here. So if I press Alt A, then I can see the animation. That's right. Okay, I can see in the from different position as well. Right, what else is pretty much we are finished. So how many frames do we have? We have 38 frames. Yeah, so all of them is 38. So one somewhere we missed a frame. Okay, let's make it 19. Now we have the correct number of frames. Oh, I don't want to save it, it's just a reflex. Okay, and I should save this animation actually. But before I do that, here in the render tab, I just changed the end frame to 38. I don't want to render the next, the other places of the animation. So that's how it looked like. Normal fire reload, normal fire reload. Later on when we create more sophisticated weapon, we have to do basically the same thing. Okay, so let me just save this out somewhere. So export and export object file, including normal and animation. And let's just go to our project folder in our desktop. So FPS game, this is it. And I will create a new folder, or I will not create because I don't know how to do create new folders right here. I have to go to the, not here, here, and create a new folder, and I call it that. Like data, rather I should call it data, and in here I will create a new folder called weapon 1. Alright, and I will save it right there. So FPS game data weapon 1. Perfect, and the name should be weapon. What else? Okay, and export this out. It should export it fairly quickly. Yes, it's already exported it. So if I go to here, as you can see, here are 38 frames. And the material files for it, and the size of this is actually 32 kilobytes, so not as big. Okay, so now we have to load this animation, pass it to the weapons, and we can test out finally this class, because this was a long tutorial, very long, ridiculously long. Okay, so stay tuned, I will be back. Alright, I'm back, and one more thing, I realized that I forgot to add this function, so the implementation to the CPP file, the load animation. So that's why I copied it from the earlier project, and I just paste it in right here. So paste it right here, that's right. Okay, and here we have the load animation function, which we can use now to load the animation of the weapon. I go up to the to here where I load the actual animation, and I use the load any animation function, and the first of all it's weight a vector of unsigned int. So let me create that vector of unsigned integers and call it anim, not matter what is it. And the first parameter is the animation, the second parameter is the animation, the name, and the third parameter is how many so how many frames do we have. So the name, that was weapons, no, that was data slash weapon slash weapon1. Okay, and how many frames do we have? We have 38. I write down here in a new document 38 frames, and the last is the reference to the object loader file, which is actually not needed right now, so actually I can remove that, the object loader, this one. Alright, since it's part of the game class, the obj file, so it can access them, it can access it right here. Alright, and I'm pretty sure that this should load the animation. Okay, so we loaded the animation. We can close the parentheses right here. The first parameter of the animation is we can pass it right there. Okay, the second parameter is how many frames do we have as a normal animation 1. Let me just exit from these files. Then we have in the 16 frames of the fire animation, and we have 19 frames of reloading. Okay, what are the next parameters? I don't really know already, since this constructor is really long. Okay, oh, the outer look is needed as well. For now let's just paste the anim 0 as the normal, as the outer loop, so the first frame of our actual animation. But you know, it can be changed. Actually, it's not even bad that we do that, since it already contains the full weapon. Okay, the next is the the position, the vector 3D position and rotation. As I said, we can't really tell that at the moment, so just create a vector 3D 0, 0, 0 and another vector 3D 0, 0, 0, and then the in position, so vector 3D 0, 0, 0, and the not in position vector 3D 0, 0, 0. We will find out from the test function which we wrote. Okay, a position, the precision, I don't know, just has some number, not really matter right now. So next one is the strength of the weapon. Again, it's not really matter since we don't have enemies yet. Then the max B, so how many bullets can it store? Let it make 30. Next one is all the bullets for this weapon. Let's make 300. Next, speed. We can shoot every 5th frame, for example. That's a bit quick, I think, so let's make it 20, so about 1 second. Okay, next thing to do is all bullets. So what? All bullets, we already passed that, didn't we? Max bullets, all bullets, speed. Oh, the next thing is the name. So the name of the weapon, I don't know, weapon 1. The next thing is automatic. Let it be automatic. Okay, so we have one weapon placed in here. Now in the destructor, let's just delete the weapon. So for int I equals 0, I less than weapons.size I plus plus, and just delete the weapons I. Perfect. Okay, and for the player we can pass the weapons 0. That's right, and I think we are ready for a test try. Okay, let's start with the last error. The load animation prototype is not equal to the actual implementation, and why not? So I just copy this parameter list and pass it and copy that to the game.h file. Okay, now it will be equal since I copied it. Now get back to the error list. Here it is. And next thing, prototype. Yeah, okay. Weapon. Here we don't have the right constructor, mean that we screwed up the parameter list. So we have to check all of these variables to be in the right place. For that, I will just copy this. Control C and comment it out and paste it right here. So we have an animation right here. Alright, actually I do that off camera. That's right, I deleted this one integer of the speed whenever I pass the name, because I forget because I thought that I screwed up, but it turned out that I didn't screw up. Okay, try again. Compiled, try to run it. Okay, and as you can see, nothing at all. Alright, what the problem is, again I go to off camera and I will get back with the solution. Alright, I'm back and I found most of the bugs, I believe so. First of all, let me start with the bad file name. So it was data/weapon/weapon1, but actually the folder is the weapon1 and the weapon name is actually weapon. So that was one of the mistakes. And let me go here to the weapon.cpp file. Here there were a few. First of all, in the test function, so I cannot rotate the weapon as I wanted. That because I rotated the current position instead of the position expected, because the current position is just stored the current position and it will always go back to the position expected. So I can rotate it and move it, but it will always move back. So the position and position expected and rotation expected should be used here. Okay, and in here where I actually move the weapon, so in the update function, yeah, here, actually I had something wrong, two things actually. First of all, that I had the subtraction in the opposite way. So originally I used the current position minus the position expected, although this will resolve exactly the opposite vector I wanted. So in order to get a vector which points to the position expected, I had to change the order of the subtraction, and I didn't have this current position plus equal the TMP vec. So although I calculated something where the weapon should move, but I didn't actually move the weapon. Okay, and yeah, in the rotation I had the current rotation somewhere. I'm not really sure about that. I have to rewatch the tutorial. I will make an annotation when I will write it, I believe so. Back in the game.cpp file, in the update show function, I have to show the player before the camera control, because whatever I call before the camera control will stay the same place whenever the player moves. Whatever I call after this camera update camera function will be actually seemed like a static object. So for example, here the weapon and the menu should be called before the control function. Between the two, the draw skybox, so the rotation applies here but the translation not. And after the update camera function should be the level and the zombies and things like that, which are not matter where are you moving, it always stays at the same place. So for example, the level, I can just say an example. Okay, and one of the weirdest error I get, actually I will show you, actually I will just show you the solution. I had some problem with the skybox, so I had to disable the disabling of the GL dev test, because whenever the GL dev test was active, some reason the weapon didn't show up. So after I commented out this GL disable GL dev test in the skybox function, everything seems to work fine. And one more thing, because I have disabled the dev test in the game.cpp file, in the update function I had to increase the size of the skybox, as it will throw too little skybox, so so I cannot see the end of the level because the skybox was small. This was all of the mistakes, and now I can compile it. So here it is, I have compiled and I can now run the program, and that's what I first get. As you can see, there is no weapon, although I can use the JKLIUO key to do several things. For example, move the weapon forward. As you can see, this is our weapon, although it is badly rotated. As you can see, we can just see a cube, but I can use the rotation functions. Yeah, that's right. So as you can see, we rotate it now in the desired direction, and I can use the J, K and these kind of keys to move the weapon in the position we want to. As you can see, now if I go to the terminal, it writes out the rotation and scaling coordinates, the rotation and the position coordinates. So we can pass these coordinates into the vector wherever we created the weapon, which is right here, and the position whenever we are not aiming should be 0.5, 0 and -1 point. So I just change the position. That's it. So what was it again? 0.50, 0.50 and -1.44, -1.44, right? And now change the rotation, which is 0, -80, 0 and -80. That's right. And now if I run the program again, of course I compile it first and then run the program again, the weapon will be the place where we want it to be. As you can see, it just started the program and the weapon is in the desired direction. Of course we could move a little bit down, but that's not really matter. I just wanted to show you why is this test function is useful. And whenever we want to aim the weapon, and whenever I move this weapon, I can make an aiming position. That's right, we should use the Y as well, so move down a little bit. So here are the position whenever we want to aim with the weapon, 0, so just copy it and paste it whenever we aim with the weapon, which is again, here it is. So -0.26, 0 -1.7. Yeah, so we should move the weapon a little bit down, so I just use I don't know, 2. Okay, I moved a little bit down, and the -80 degrees is alright, as you can see. So we just filled out the rotation and location variables of the weapon. Now actually we have already the function which aiming and do such things, but we actually never call those functions, so we should call them. So I can press any mouse button, but the weapon will not react as it should. So in order to do that, first find the main event loop in the game.cpp file, so with a lot of case statement, and here we are actually. First of all is to add add a switch statement to this game down, so switch event.key sim, so get the key code, and if we just press the 0 key, so SDLK_0, then just get the player's current weapon, so player 1 get current weapon, that's right, and change the weapon. So you know what, no, the player has the change weapon function, so just simple change weapon and change the weapon to 0, for example, and break. Similarly, I do that with 1 and 2 keys. For now it should be enough, so this is just a demonstration. If you want to add more weapons, you can easily do that. So 1, 2, right, okay, that's enough. And now whenever we press the key, we already have a case statement for that. Let me break here from this switch. Okay, I already have the mouse button down, so in this case we just simple fire the weapon. So get the player 1 and then get the current weapon, get current weapon, and just simple use the fire for that. For now I just call the fire, I not check the returning values, although this will require an vector 3D object called I don't know, direction. Okay, and we should define that somewhere like here. Okay, this will be the direction which will be returned, direction, and the second value is the camera direction. So player 1 cam dot get direction, or no, it was get vector, I'm pretty sure about that. So we pass the current looking direction and we get where the fire occurred. Okay, that's right. And one more thing, reload. So if we press the R key, we will reload the weapon SDLK_R. Then we just get the player 1 get current weapon and just do the reload. That's right. So whenever we press the R key, we just reload our weapon. Alright, did I forget something? Of course, the mouse scroller. Actually, we will add that later, it's a detail. But the more important thing is that the stop fire function. So whenever we release the key, we should stop firing. So I make another case statement right here. So mouse button up whenever we release the mouse button. Then actually we want to, so we don't want to fire anymore. So player 1 get current weapon and just use the stop fire. Stop fire. This will stop the firing and the break. And whenever we press the right mouse button, we should also aim with the weapon. So get mouse button down. So we should examine what mouse button was actually pressed. We can do that by examining the value of the event.button.button. So here I just examine it. So if event.button.button is equal to SDL, it is equal to button underscore left, then we do the firing stuff. So we fire as if it is the right mouse button. So event.button.button is equal the button right, so it is the right mouse button, then we aiming with the weapon. So player 1 get current weapon, and we call the aim function for that. And here actually we can add the wheel up and wheel down. So as if, so if it is wheel up, if I type it correctly, so SDL button left actually. So this is an SDL underscore button left, SDL underscore button right. I don't really used to check this, that's why I don't really know the constant's name. And this is called, I have a cheat sheet right here, so this is called SDL button underscore and wheel up. Yeah. Then we change the weapon up. So back here. So player 1 and change player 1 change weapon up. Change. And we have one more else statement, else if, and if it is the wheel down. So if we use the wheel in the opposite direction, so downward, then we change the weapon down, obviously. So player 1 change weapon down. Okay, that was pretty much it. So now I believe we should be able to compile it, of course after a few bugs or errors, I would rather say. Yep. Stop fire. If it was not stop fire, what was it? Stop fire with a not capital F. Stop fire, where did I call that? Key mouse button up, yeah, with a not capital F. Okay, let me try again. Alright, and let's run it. So, let me try the key. Okay, I'm pressing the left mouse button, and as you can see the weapon is shooting. And if we shoot out that 30 bullet which we have put into this weapon, we should get a reload, although it doesn't seem like that. Why don't it reload? It should reload. Not sure. Okay, as you can see the aim is a little bit down. Okay, we can shoot. The reload animation is not working. I press the key R and it's not working at all. Why it's not working? So let's go back to the weapon.cpp and find out why the reload is not working. So reload, I have to find it first in order to debug it. Stop reload. Here it is. So if we are not reloading yet and the max bullet is not equal to bullet.mag, then the is reloading is true. Everything seems to be alright in here. So it's firing. If we are reloading, then we are returned with false. Yeah, not sure actually. Normal animation plus fire animation, and let's go back to the update and check it out. Update, here it is. If the normal mode is free, the current mode is free, then reload animation, everything seems to work fine, but I'm not sure why we don't have reloading. Okay, first of all, let's include the up down into our test function so we can better position our weapon. So we need two more keys in here. So if actually just copy it to save time. So what keys should I use? I should use the Z underscore Z and the letter T. Oh wait, no, here T. Okay, and this will change the Y position, Y minus equal and Y plus equal ZT. Okay, so we can, if we start the program right, compile and start the program right now, we can oh wait, one more thing, it is a Y as well. We can manipulate the Y coordinate of the weapon as well, so we can place it better on the screen. Okay, so let me use the Z and the T key. Was it Z and T? It's not working. Why it's not working? Position expected Y. Not sure. Let me run it again. Z and T. So T, Z, T. Nothing seems to work. It is working, but the T and Z is not working. Why is the T and Z is not working? If keys SDLK, Z and T, position expected Y. It's a good question. Have no idea. Everything is just a copy of that, and I changed the Z to Y. You know what? I will be back when I debug this. Alright, I'm back, and actually I haven't done anything. It just fixed itself. Not sure why actually. So now we can place the weapon, the place we want the weapon to be. Okay, so this should be our not aiming coordinate, so I should make a print screen about this so I can remember the numbers. Alright, save it. And the aiming coordinates, let's just go here and a little lower down. Oh, that's perfect. Okay, let me make another print screen, and this should be our aiming coordinates. Perfect. Now I just copy this not aiming and aiming coordinates into this vector. Hold on, I will stop the camera then. Alright, I'm back, and here is the new weapon. So aiming, not aiming. So this is the two position, and now you have seen why is the test function is important. Next order of business is to find out why the reloading is not working. So reload, nothing is happening. Okay, again, I will go off camera while I figure that out, and I will be back. Okay, one of the great mysteries has been solved. I forget to place the case in here. I'm actually wondering how this could have been compiled at all. It should be a syntactic error, but anyway. So I forget to place the case everywhere in here downward, so it wasn't so of course it doesn't call the reload, and now it does. The next thing is that actually it will not call the reload whenever we are shooting, so it doesn't seem like this reload is called ever. But I'm not sure about that, because maybe that's too many bullets in this weapon. Let's decrease the number of bullets in here to 10. This was it? Not sure. Go back to the constructor to see. Max bullets, this is 1, 2, 3, 4, 5, fifth character from the back. 1, 2, 3, 4, 5. Okay, this is it. Now it's only have 10 bullets. Let's compile it and run the program and see if it is called now or not. Okay, here it is. As you can see, now I can reload if I shoot any bullet. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not reloading. Why not reloading? Should have been reloaded. That's an interesting question. First of all, let's write out if it is called. So in the fire function, if I find it, let's just write out the bullets in mag, this variable. So std cout std and line, and let's see how many bullets do we have. So it is decreasing and reach the 0. So fire. First of all, we should make the isTest equal to 4, since I can't see anything, just these tests. Okay, so isTest equal to 4, so we don't need to check those values anymore. Run. Sometimes it doesn't load the weapon, I'm not sure. Okay. When I continuously holding down the key, it doesn't seem like the number of bullets decreasing. I'm wondering why not. So if I continuously hold down the key, but still the animation plays. So in the fire function, probably I have screwed up something. So if it is not automatic, if it is actually automatic, so this will be false. So this is automatic is actually true. Oh, right. So we only call this fire function actually once. So in the update function, if we are so yeah, we should use a boolean value to store whenever the key is whenever the button is pressed. And as I said earlier, in this update function, this is actually a bug, which is I added a comment here. We don't need this if and as. So in this case, this is a semi-automatic weapon only. So now if I press the key once, so it is a semi-automatic in this way. That's because we only call this fire function when the key is pressed, but not when I hold down the key. So I should use a boolean variable for that. So bool mouse button down, and this is equal to false. And whenever we press down the mouse button here, I just change it to mouse button down equals to true, and I just copied this, and whenever I release the key, so here I just use the mouse button up down equal to false, so it's not anymore pressed. And here, before I do this update, for example, I could check if the mouse button is down, button down, then I call the fire function mouse button down. Right, so now it should be fully automatic if I change it to fully automatic in the boolean value. So now if I holding down the key, yep, perfect. 3, 2, 1, 0, reload. Yeah, that's working. And I think this should conclude the tutorial because it was ridiculously long already. Okay, thank you for watching, and in the next tutorial we go on to the zombies. So thanks for watching, and